negative parts. Let's look at an example. Scores on an exam are normally distributed with a mean of 65 and a standard deviation of 9. We want to find the percent of scores satisfying A, B, and C here. In A, we want the probability that X is less than 54. So for X equals 54, the corresponding Z-score is 54 minus 65 divided by 9, and that gives negative 1.2222 repeating. Since the Z table is set up to handle only 2 decimal places, we round this to negative 1.22. We then go to the Z table and look up the area. For Z equals negative 1.22, we go to the negative side of the table. Look for negative 1.2 in the first column and 0.02 at the top. The corresponding area here is 0.1112. That is, the area to the left of Z equals negative 1.22 is 0.1112. So on this normal curve, for Z equals negative 1.22, the area on the left here is 0.1112 as seen on the table. Therefore, the probability that X is less than 54 is the probability that Z is less than negative 1.22, which gives 0.111 or 11.12%. In B, we want the probability that X is at least 80. In continuous distributions, like the normal distribution, there is no distinction between X is at least 80 and X is greater than 80. We apply the same approach in both cases. So for X equals 80, Z equals 80 minus 65 divided by 9, and that gives 1.67 to 2 decimal places. When we look that up in the Z table by checking 1.6 under 0.07, we find 0.9525, which is the area to the left of Z here. We then subtract it from 1 to obtain the greater than area, since the total area under the curve is 1. Therefore, the probability that X is at least 80 is the probability that Z is greater than 1.67, which equals 1 minus 0.9525, giving 0.0475 or 4.75%. In C, we want the probability that X is between 70 and 86. For X equals 70, Z equals 0.56. And for X equals 86, Z equals 2.33. On the table, the area less than Z equals 2.33 is 0.9901, while the Z equals 2.33 is 0.9901, while the area less than Z equals 0.56 is 0.7123.